Here's a neat old Delco radio. Let's get this thing working and see how well it performs. It's a 6-tube design, so it's an all-American 6, which means that it has an RF amplifier tube in the front end. A lot of these radios are all-American 5s, which mean they only have 5 tubes in them, so this one should receive very well. So let's get this thing apart. Very easy to get apart. All you have to do is just pull the knobs off like so. Little white spacers behind and white knobs on a dark colored radio is very uncommon. Now to get these things out of the cabinet, it is really quite simple. Almost all follow this kind of idea. So on the back side, usually there are some screws on the top here, which there aren't in this radio. We can see 2 screws here that hold the back on, and there's 2 screws down in there, one there and one there, that actually hold the chassis into the case. So if we just undo these 2 screws, this whole thing should just come right out as one piece, which makes these things very easy to service. Way back in the day, a lot of people would just take this off and move the antenna down to replace the tubes. That's okay as well. You don't have to remove the knobs, but I like to just remove the entire chassis, and it allows you to look underneath and see what's going on as well. Now, you may notice already that in here, it's an ivory, kind of a whitish ivory color, but yet on the top, it's a dark color. This tells me, you can see here, it's ivory as well, that somebody has stripped the paint off this at some time. And they did such a good job of it that if you weren't really looking for it, you wouldn't really suspect it with those white knobs on the front. So just leave the screws in there, that's fine. This cord is pretty brittle. You hear it cracking and popping there. So I'll tip this like so, hold this in like this, and then all you have to do is just give it a bit of a shake, and the cabinet comes off just like so. So you can already see that somebody has pulled off the dust cover on the speaker. Some crust down in the bottom there. The top of the chassis is looking really nice, so you can see the 6 tubes. 1, 2, 3, 4, 5, 6. So it's a mix of metal and glass tubes. Nice tuning capacitor there. Internally, it's looking like it's in pretty good condition. Move this around. The chassis isn't looking too bad. It's just discolored. Not bad at all. So let's see what's going on the bottom side. This is always interesting. You see the nice little wax capacitor that couples basically the circuitry to this wire sticking out of the back. So that should always be replaced with an X1, Y2 rated capacitor or equivalent. Oh, look at that. Somebody's been in here. It's a mixture of modern and older components. What I'll do is I'll get this fixed on the bench here, zoom in, and we'll take a closer look at what somebody else has done to this thing. Lots of components have been replaced under here. You can see all of the newer style components. Looks like they've even replaced some carbon composition resistors here. Their capacitor down here. Lots of parts have been replaced, so somebody had made the effort to try to restore this. They left the original filter cap in, which is one of the biggest troublemakers in these radios. And they left one larger wax cap in here as well. So replacing this filter can, this filter capacitor, and this one wax capacitor should pretty much make this okay just to try out and to see if this thing will actually come to life and then go from there. If it does, it'd be neat to give it a quick tune and just see how well this thing performs just the way it is. So what I'll do is I'll get rid of this cap, and there's actually 2 capacitors in this, and I'll get rid of this cap here, replace the line cord, and let's see how well this thing performs. We definitely can't power this thing up with a line cord like this. So this is some pretty bad stuff. And in fact, in one spot it was twisted around. I untwisted it here. You can see that. It's completely bare and it was completely twisted. So bad stuff. So what we need to do is get rid of this first. So what I'm going to do is clip this here to get rid of the line cord. I'll clip it here and here. So we'll get rid of this knot. Now you'll see this knot here is dragging on this shaft. You can actually see a polished spot here. I don't know if you can see that. So not a good thing. The line cord should be away from this because, you know, as you're turning the dial, right, you're spinning this shaft. And as you press the push buttons on the front of this, this spins to, you know, bring the needle to where it needs to be. What ends up happening is it's going to give that line cord an abrasion, right? And eventually it could wear through. So that's something that the line cord should be pulled off to the side over here and then ran down over the side over here. The new line cord, what I'll do instead of tying a knot here is I'll put 2 tie straps, zap straps if you like, zip ties, and you got all sorts of names, on here on the inside, and I'll pull them tight. And then usually what I do is I put a drop of super glue on those zip ties, and that's quite a bit better. You don't have this big knot on the inside here that can rub all over everything. It just keeps things much cleaner, and actually it's a much better restraint than having a big knot that can untie itself, kind of, right, and get loose and sloppy like that, right? So to get the wires off, it's relatively easy. You know, just heat the terminal, and these tube sockets are pretty resilient. You know, you just do it like so, right? Take them off, and over here would be the same thing on the switch. So I'll just move the radio around so you can see that. Another good thing to do is, if you're relatively new at this, is to actually take pictures of this before. You know, many people now have smartphones, and they very quickly and easily take pictures. And you can take a picture of this if you need that. Now, if this all does go well, and I actually go about putting the time into fully restoring this, the line cord system on this will be completely changed around. You're probably saying, well, why would you do that? Well, you can see here on the plug, so this is the schematic for the radio, obviously. You can see on the plug we have a switch to ground. So what they're doing is they're opening the neutral side, and the hot side runs directly in. So this will also run on DC as well. So these sets that don't have a power transformer in them will run on both AC and a DC source. So technically, if you made 120 volts with batteries, you could run this radio on that as well. So, you know, relatively versatile set. So what they do is they put the switch from the factory in this side here. And the reason that they do that is because the switch itself is on the back of the volume control. And what happens is they were concerned back in the day that having the hot lead run to this might actually induce a little bit of hum. Well, really it doesn't. And I've done enough conversions to realize that, you know, the hum is really just, it's not existent, you know, no more than having it the other way around. So I'm sure they had other reasons for it as well, but I can see that being the major reason. So in order to make this safe, this line here has to be tied directly to ground. So the neutral goes directly to ground, and the ground is very close to the chassis. It's isolated by a capacitor over here. So the ground doesn't tie directly to the chassis. It ties, or the neutral, I should say, doesn't tie directly to the chassis. It ties to a ground. The chassis itself is AC coupled back to this, all right, through this capacitor right here. So to keep things safe, you keep the chassis as close to neutral as possible, and you want the neutral tied, you know, to the ground point, and then the hot point switched. So there should be a fuse. The fuse should be first. People, you know, often say, Paul, you should put the fuse after the switch. No, you shouldn't, because if the switch shorts or something like that, the fuse should always be the very first thing in line. That way everything beyond the fuse is protected. All right, so the fuse goes first, and then that goes to the switch. So this switch would be moved up here and then down into the rest of the radio. So, and that would happen in the case of, you know, after we try this thing out and go towards a full restoration, that would happen. So everything would get moved off this post right here, and you know, we run the hot over here and then back over to this side here again, and the neutral would just run down over to this point underneath here, right? Because this here ties to this point down here. So a little bit of a changeover, but it makes things a lot safer with these All-American 5 and All-American 6 style radios. That's a conversion for safety that should be done. So what I'll do anyways, I'll put the line cord in here just to try this thing out. I'll move the capacitors out of here and put some new ones in, and we'll give this thing a try. This is the line cord that I'm going to use to replace that other cord. It's 12 feet long, and that is quite excessive, but I will leave it 12 feet long just for the trial here. And if I go about doing the full restoration, I'll cut the cord down to a reasonable size, and I'll use the rest of the cord to do the wiring for the fuse and everything else inside this radio receiver here. This can be found at most hardware stores, and they're pretty reasonable. It is a polarized line cord, and there's a lot of it there. So I'll be installing this here in just a moment. The line cord is tacked in at this point, so this isn't permanent. Again, we're just trying this thing out. I did put the zap straps on there just to stop this from pulling out. So that's normally what I would do. I would put 2 tie straps, zap straps, zip ties, whatever you want to call them, on the cord, and put some super glue on them, and then they're held tight in there. So the only thing that would cause this to keep splitting down here is, sideways motion, and it's pretty limited at this point, right? So I think I could probably just get away with both of these in here. Again, this is just loose. I'm not really worried if this is going to touch this right now. It would be completely redone. This would be ran close to the chassis in a restoration all the way to this side. And then, of course, these 2 wires here, I would take the spare cord that is not used, and I would actually run it joined together like this along the chassis to keep things nice and neat up to the switch. So you might be saying, why am I going through all of this just to see if this thing is going to work? Well, there's a bunch of warning signs with this particular radio. One thing, they stripped the entire case. They did a really nice job, and they stopped. And now, in order to get the case stripped the way they did and looking so nice, like they really did a good job, taking all of the paint off of this case, right? You can see the remnants even in here, right? So you definitely know it was ivory. So they did a really good job. There's an incredible amount of work getting it to this particular point, and they just stopped. And they left the original filter in, and they left this cap in. They just kind of stopped. So what's wrong with this? Is the speaker shot? Is the audio transformer shot? Are any of the IF transformers shot? Maybe all the tubes are weak. A lot of the times these radios were left on 24 hours a day in different applications. Sometimes these things were put in barns. This thing I don't think was. The chassis is looking pretty good. It may have been, you can see there is some water damage on the back. So if every single tube is weak, that may have stopped them. That wouldn't stop me because I have, lots of vacuum tubes. So I'm not really too worried about that. I'll just replace the entire line of these things. But, that is a warning sign. So what we want to do is definitely try everything out before we go through and go any farther, and let's see what stopped them from actually doing this restoration. Or was it just they lost interest, right? You really don't know at this particular point. Anyways, so that's where we're at. If I go through and do an entire restoration on this thing, I'd take out everything that they've done pretty much, and put in the capacitors of that I prefer, and mark the foil side and do all that kind of stuff, and of course everything will continue there. There are quite a few mistakes in here that I see. The person that was working on this obviously didn't understand things. You can see the audio transformer power lead. So this is a DC power lead that goes to the transformer. This feeds the B+ to it. It's right up against the oscillator coil. So the oscillator coil should have absolutely nothing close to it, and definitely no wires leaning up against it, because that will incur drift in the oscillator section. So they have special capacitors here. I'll zoom you in. They have special capacitors on this coil that are rated to compensate for drift. And these are ceramic tubular style capacitors, and many times these will have a coefficient, N750 or something like that in parts per million. Now on the schematic, you can see that they've got their own little symbol for that. It doesn't really need to be like this. I don't know why. A lot of these radio manufacturers back in the day, they kind of just almost created their own symbols. So this little resistor symbol that looks like it's center tapped is a temperature compensated capacitor. That's their little symbol for that right there. So we have 2 of them in here. So there should be another one around here somewhere. Another temperature compensate. Yeah, there it is, right down in there. This one right here. So there's 2 temperature compensated capacitors. That's what they call them. They're ceramic tubular capacitors. Another thing is you don't ever want to change these. These very rarely fail. If you change these with a standard ceramic capacitor, you'll need to put a steering wheel on the tuning dial in order to keep the thing on frequency. So definitely don't be messing with those. So they very rarely fail. I think in my entire time of working on radio receivers and transmitters. I think the only ceramics that I've ever replaced like this were in a transmitter application, never in a receiver of any particular type. They just don't fail. So anyways, so that needs to be addressed. So this would have to be moved in the restoration. And I've noticed that they've also, you can see on the coil here, we have a lead that's jumping over this. It's touching other leads. You know, it's got a nice burn on it down here. See if I can get you in any closer. Move this over here. So this is running over this. It's actually laying on this and running down to this post. So this is, you know, a very sensitive connection, right? So this here should be in free air, not touching anything. So very low, any type of capacitive coupling to any surrounding components would be very low. So not bridged over this terminal nice and tight like that, touching this wire and this wire and this wire, right? So this needs to be addressed as well in an entire restoration. These are the little things that really screw up these restorations for other people, and then they get a very bad idea of how these radios perform. So these radios are very hot receivers when they work, and when I say hot, they receive incredibly well. They're great for late night DX, for listening to distant stations. This thing will listen to radio stations for thousands of miles. No kidding, thousands of miles when the conditions are right. I'll hear stuff right across North America with this. So they are incredible receivers, but you know, things have to be done correctly in order to make them work, you know, top notch. So now the thing that we really need to address is, why did they leave this wax capacitor in? They changed out all the other caps. You know, they've put in poly caps in here, obviously not taking note of the foil side, right? But they've put in poly caps. This one here is, yeah, I don't know why they left that in there like so. So what we need to do is remove this and find out what's going on. Maybe they tested it and it's okay, which I highly doubt. But maybe they did. So I'll remove this cap and tack a newer cap in here, and I'll tack 2 filters in. So these are 40 mics each, right? So they mark things a little bit funny, again, back in the day. So this is 40.0 and 40, you can see the little decimal there, 40.0. That's not 400. That would probably take the bonding wire off the cathode in the 35Z5. That would act like as a little fuse in there if you put a 400 mic cap on this side. So that's 40 and 40. So 47 and 47 are the new modern equivalent that would work absolutely fine in that. So I'll tack 247 microfarad capacitors in place of this here. So in place of this cap here, because this should go, because this capacitor here is a real dandy. All right, both caps are out. Let's try them just for the fun of it. All right, so I'll put this into the leads here, like so. And let's see, let's dim this out just a bit so that you can see this. Okay, so here we go. That's moving pretty slow. So again, this one here is that wax one that they left in. So it's probably going to stop on that lamp or the next one. It's pretty slow at this point, as you can see, nice and red. So we're on the red scale here. Zoom on into that so you can see that. So anyways, may as well just stop that test. And I'll show you a good one just for comparison here. So we'll put the new one in. So this will be the one that'll be replacing it right here. All right, so just put that on, and here we go. So this is the red scale in the mega ohms. And now it'll flip scales to a gig ohm scale. That's in the gig ohms now. And this will go way high up into the gig ohms. That should go green. And that is a very good capacitor. That's how they should be. So shut that off. So there you have it. That's what will replace it, and that would get replaced in all of these. Now these capacitors here, just brighten this back up again. So this is the electrolytic capacitor. So this is 40 and 40. So I'll just grab this. Let's just test this with a modern tester here. So I'll turn this on. Get the glare off of that. Turn the backlight on. It kind of helps. All right, so let's test this one out. So this will be one section. Hopefully you can see that okay. It's going to measure it. We got measurement. Oh, we did have measurement. So 60 mics on one. So they're rated at 40, and that's showing 60. All right, now these older caps do have quite a wide tolerance to them. Let's see the other one. That's the other portion, so there's two caps in that one, right? So let's see if this is gonna, so that one's almost 63, all right? So, you know, could be quite a wide tolerance to that, right? But we really don't know until we test it for leakage. So let's see what happens here. Shut that off. So I'll go to electrolytic here. Let's test this one for leakage. Let's test one section first. Test this one here. Okay, so I'll zoom you back in. And darken things up just a little bit so it's a little easier to see. That should be okay. And here we go. Moving okay up to about this point right about here. It's starting to slow up pretty good. So definitely leaky. So it tests 60, but it's leaking. So we'll just discharge what's in it. Let's try the other half, see if the other half is doing the same thing. This is the reason that these caps destroy these radios, right? They destroy the rectifier tube. Here we go. So they're both in the same can, right? So I imagine they're probably going to both be very close, right? Because they're kind of immersed in the same electrolyte and everything. This is a dry electrolytic, I believe. Yes, it is. It's a dry electrolytic. Yeah, so it's going to stop there. So now what we'll do is we'll take a new one. This is 47 mic cap. And we'll put one of these on here. And this is a new cap. So put that on there, and here we go. Wow, look at how fast it buzzes at the second scale, right? And that's a brand new cap. That's the reason that you replace those old caps. Now, one of the things that's kind of confusing is when you test these, they almost look like they're overachievers. And sometimes that can be very, very confusing because these things did have quite a wide tolerance on them. But the reason that the meters, a lot of the capacitor testers read high with these things is because they take longer to charge because they're leaking. And when they do leak, of course, you know, it kind of mimics a resistor across this, takes longer to charge. And of course, newer capacitor testers measure the amount of time it takes to charge the capacitor to give you a capacitance value. So the leakage tricks the meter. So in this case, this is definitely a leaky cap, and it is on its way out, right? So if you were to leave this in the radio, that could very well destroy the rectifier tube. That's why these always have to go. So I released this thing quite a few years ago, all the plans to build these things, like this particular piece of test equipment, I have another one that's like this as well, are up on Patreon. I release all the alignment procedures and printed circuit board layouts and everything like that if you want to build one of these things. Very handy to have on the bench, and again, tells you where your modern meter would trick you. 2 new electrolytic caps have been installed, the paper cap has been replaced, and I'm ready to try this thing out. I have this plugged into my isolation transformer and current limited variac supply. So again, this is a hot chassis type set. So whenever working on anything like this, an isolation transformer is a very important thing to have. If you're following along, you're doing so at your own risk. Know that this is an AC operated device and there are elevated voltages in radios like this. Anything with vacuum tubes has elevated voltages in it, aside from space charge sets, and some space charge sets even do have elevated voltages, but they are kind of the exception to the rule. Anyways, so here I go. I'm gonna flip this thing over and turn it on. See if we can get maximum tube glow happening here. We'll zoom on in. This here, and the dial light's usually a really good indication as well. Hopefully it works. Turn that off. And here we go. So this is current limited right now. So I'm just going to give it everything. Here we go. What I'm going to do as well, which I probably should do, is maybe put a knob on this one. That way they're a little easier to turn, like so. Okay, here we go. That's a good sign. Maybe we'll put a knob on the tuning shaft as well. That way it's a little easier to turn. There we go. Oh, I hear hum. You hear that? Quite a bit of hum, actually. Get close to it. Turn it up. There is static. Back here just a little bit. So all the tubes are glowing. That's a good sign. So if one of the tubes is burnt out, so if a filament, say this tube right here is burnt out, none of them will glow because they're like an old Christmas light string. They are all in series. So if one burns out, none of them glow.
Oil's outfielder told a story to me one time about Bojack.
There are stations, so it's trying. This is a good sign. That hum is really loud though. I don't know how to turn this down. You can hear that? Get that close to the mic. That's really loud. So maybe that's what deterred them.
Life-changing stations across BC. Every step of the way.
There is life. Now there's very little reception. There's very little reception down here in the lab because, well, it's way down here. So I will have to use an external antenna, and I'll talk a little bit about that here in just a moment to get signal in here because this just isn't going to cut it down here, right? So I've created a thing called a power antenna, and I'll show you how that works here in just a moment. It'll couple to this from a distance, so I'll be able to bring the signal down here without actually attaching any wires to this radio. Now I'm going to perform an IF alignment on this before we do anything, and I'll even peak up the RF on this so that we can see how this will perform with these tubes and see if we can get any better performance out of this thing, and I'm going to also use that as well. So this new device that I've created will sit off to the side. I'll show you this here in just a moment, and I don't have to connect anything to this radio to do an alignment. Nothing whatsoever. So I don't have to connect anything to do an IF alignment, an oscillator alignment, or the antenna alignment on this thing at all. So it makes working on these things much, much safer. And I know I've had many people ask me about that. They have concerns about tying their test gear into these types of sets, even on an isolation transformer. And this just makes this an entire world different. It's so much safer to work on. I'll display that here actually right now. I'll get the power antenna hooked up and show you how that works. I'm pretty much ready to go with the IF alignment. So this here is the power antenna circuit, and it's just junk box parts. Basically, it's the back of an old radio. There's a compactron tube here on a little chassis, and then this runs off just to an external bench power supply. And what this does is this basically just casts the signal into this radio right here. So I can tune the IF without actually having to connect to this thing. And it's very simple, and I'll give you an example. So the IF frequency of this is 456. It's not 455, and that all has to do with RCA back in the day with their iron fist, basically. So people used 456 instead of 455. So this is 456. The signal level is down to nothing right now because it's not putting anything out. And it's a 400 cycle tone modulated at 50%. You probably can't see that, but it's 400 cycles, so that's the tone it's making, that it's modulating this with, and it's at about 50% mod. Okay, it doesn't need to be any higher than that. You know, you can make it 60, whatever. It really doesn't matter. All right, so this is the cable that's running over to the power antenna right now. So I'll show you that here. You can see that running over to the power antenna right down here. So it's coming right in here. And if we take a look at the radio here again, so I want to be aligning these points right here. So this capacitor, this one here, and then there's one up the front here. So those are the 4 that we'll be aligning. So what I want to do is bring this right to the bottom of the band. And I'll turn on the signal generator. So I'll give this some RF. And look at that, how far away it is. So I'll turn the RF level down, we'll say. So I'm driving this over here with about 1 millivolt, so 1,000 microvolts right now, sitting at this point right here. Now keep in mind, this is the IF, this isn't the RF section in this thing, so it's getting right into this thing. And I probably can turn it down even more than this right now, depending on the sensitivity. I don't know how badly aligned this thing is. So over the years, these things get screwdrivered pretty bad. So again, yeah, just junk box parts. Very easy to make. This is on Patreon as well, and I share all of this with everybody there. These are very directional, right? This antenna is directional as well. They all are. So you can see here, if you listen to it, so if I don't have them phased correctly, you can see that I can even vary the intensity just by doing this. Right? So very handy to have. So what I'll do is I'll just, let's try peaking it up and see what happens. Right at the bottom of the band here. This is max volume right now. You can hear that tone. We're listening for a louder tone. Okay, so I'll start with this one right here. See, look at how much gain we got out of that. Let's go to the next one. So we're just tuning for the maximum amount of tone, really. We just want the volume of the tone to come up. And this can be done by ear. You don't even need to put a VTVM or anything across it. It's very, very noticeable like this. Wow. So I'll have to turn, I can either turn this or I can turn the signal gen down. So I'll turn this down. So let's go 100. So that right now is 100 microvolts into this. All right, now keep in mind, this isn't the RF, this is getting into the IF section here. So it's working pretty well. So let's try and peak this up again. Go to the next one. Wow. Look at how far off that is. So go back up to this one. And over to this one again. Wow. So turn this down. 50 microvolts. This one here. Turn the volume down. Go back over to this one. All right, so turn that off. Wow.
Rated by Sherry Punjab.
Look at the sensitivity that we gained just by doing that IF alignment. And that's all we've done. We haven't even peaked up the antenna circuit or anything yet. The fact that this thing is even receiving like this down here is incredible. So, as I say, there is no reception down here. So that is very impressive for this receiver. Keep in mind that this is the string of tubes that it has, so all the tubes are working fine. The hum is a little bit interesting, that would need to get looked into, but it's just totally come right to life. And look at that, nothing attached to it, all done with no test equipment, and no test equipment tied directly into this. Now, this is very important because I've talked about this in many other videos. When you attach test equipment into a radio like this or anything, the test equipment has the ability to drag the alignment because you load the circuit. I always say the best alignment is done when the test equipment is invisible to the device under test. And this is about as invisible as we're going to get at this point. So that really worked out quite well. And we can even do an RF alignment on the dial and everything. It seems to be working right now, just enough to test it, so I'm not really too concerned about that. But like, listen to the sensitivity of that. That's just way up there. What a huge difference. See, this is topping out right here. That's just topped out, so it should actually go above 1700. So, this would need to get slid along the dial string. I think the dial string in this thing needs to get replaced. The dial string itself is looking kind of frayed in some spots. So that would be another thing that would have to go. So yeah, this is definitely going to get a restoration now. So I'll take you along for the ride as I do that as well. I'd like to restore the case. And yeah, so I don't know, maybe the hum deterred people, or maybe a bad alignment. They couldn't get sensitivity out of it or something. I really don't know why the restoration or the repair on this thing stopped like that. So, but anyways, incredible difference right there. So the IF alignment is done, and this could probably be peaked up at the top end of the dial. On the alignment sheet here, they want the antenna, yeah, 1720, so that'd be the top, right? Or no, the antenna they want done at 1400. You can see that right there. At 1400 they want the antenna peaked up. So we would go to 1400, which would be somewhere around here. I can put 1400 on here and we'll peak it up at that point at any rate. And in order to peak up the antenna, we have to turn that little adjustment screw right there, which is a little trimmer capacitor. And that again will peak things up. So what I'll do is I will turn the signal generator to 1400 AM, 1400 kilohertz. I'll turn this on, and that's at 50 microvolts. So let's see if we can find this. There it is, right there. So that would be 1500 on the dot. So this is, that's 1400 right there. Okay, and now what we want to do is peak that capacitor up. Really line in the way, big piece of wire in the way. Wow, that was pretty stuck. So look at the difference that made. So we even have more gain on top of this. This thing is going to be a very hot receiver. So now, because there is no reception down here, what I'd like to do is take this and now attach this to my external outdoor antenna. And it'll take the signals that are coming from my outdoor antenna and cast them over to the radio here. And they'll do it actually from quite a distance. So what I'll do is I'll undo the coax from the signal generator over here. So I'll undo this. And I'll move this on the other side. Let's move you up here to the antenna post. And we have a signal in there right now. Turn this down.
The charter of race.
Played Miami, or he was.
Republicans now cap.
And it is.
Wow.
It was invented by Dr. Frank Robert Wake, a psychology
So
professor out of
I'll
Carlson
disconnect
University.
the antenna from
He
this.
based his machine on a study done in the United States that measured the pupil sizes of
Completely gone.
United States by the Canadian government to study similar devices used there.
So you can see, and it works from quite a distance as well. So weak station there.
The biggest waters in the world, but you gotta have some TV steps. You gotta take in between to actually achieve your goal. We call those,
Can move this way out of the way. You can see how far away that works. Again, remove the coax. Station's gone.
It's one of the things where, I was trying to tell a lot of kids, and we didn't realize too much. Trying to break it down.
This thing is working incredible. So I don't know why they stopped the restoration on this. So definitely this is going to get a restoration. It's a very, very sensitive receiver. And it sounds fantastic as well. Let me try the tone here.
Would analyze the size of the subject's pupils.
It actually fits. Yeah, like double digit sats, so like 7.5.
It's gel in their hand as they.
Most people's life like.
Setting a return date until testing. And the world famous bologna burger.
In this journey taking place in.
So it's working very, very well, and it was just as easy as that to align. So if I restore this thing, technically I have to tear this thing all down again, but anyways, it was nice to see that this thing is actually working. So it looks like the person that did this the last time just gave up on it. And that, unfortunately, is kind of sad for that person, because this thing really is quite a hot receiver. So as it says in the picture, wow. Yes, wow. I'm really quite impressed with this. This All-American 6 is just, it's going to be great. I'm really looking forward to restoring this. It's just going to get better from this, So once it's restored and all the new components are put into it, all the tubes are tested. If any of them are even kind of weak, they'll get replaced. And this will be a great late night DX performer. No problems whatsoever with this thing. So definitely 2 thumbs up on the restoration of this, and I will take you along through that entire restoration process coming in the very near future. I hope you enjoyed today's video. If you're interested in that alignment tool, the power antenna circuit, it's a part of my ongoing Patreon electronics course. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.